So what you guys don't know is that this is my third time trying to record this, and for some reason my video making things has not worked very well. So if I go really fast, it's because I've done it a couple of times, and it's kind of yeah, I don't know what to say. It's kind of, but anyways, so here I go again. Hopefully this time it works. The third time's the charm, and I'll go through this, and we can learn some of what you guys hopefully started to discover on Math is Fun. Now realize Math is Fun, those assignments were to help you guys learn some of this stuff and try to get your mind start to thinking in this matter. Okay, I didn't expect you guys to have 100% mastery based on what you did on that. So I'm going to go through some things, and then we'll start working on some worksheets and some different things like that. But I wanted to go through and explain some of what you hopefully learned by working through and reading through some of those web pages, okay? So the first thing, this says it's arithmetic. If it's arithmetic, that means we add the same amount each time, okay? So if I look at this, the bottom stays as 4. So that means I must be doing something to the top. So I look 1 to 3, 3 to 5, 5 to 7, 7 to 9, 9 to 11. That means I'm adding 2, but be careful. You're really not adding 2. You're adding 2/4 or 1/2. We call that the common difference. Okay, and if you were to take any two consecutive terms and subtract the term on the right from the term on the left, you would get the difference every time. Like 9/4 minus 7/4 is 2/4. And so that's the difference, okay? Now, any arithmetic sequence can be written as a general equation, okay? So this will generate whatever term I want. The first, second, third, that's what this n stands for, that's the term that I'm after. Now this has a c right here, and it's like, well, what's c? We know what d is. D is the difference. N is the term number we're after. But what's c? Well, c is a1 minus d. I like to think of c as the term before the first term. Okay, so what's the term before the first term? If I go a half back this way, it's a negative 1/4. So we can plug it in this and calculate it into this formula. We can go 1/4 minus 1/2. 1/2 is the same as 2/4. So 1 minus 2 is negative 1/4. And that is c. So now what that has given me is I now have a general equation. an equals 1/2 of n minus 1/4. So say I wanted to find the 1, 2, 3, 4, 5, 6th term. So this is my first term. This is n equals 1, n equals 2, n equals 3, n equals 4, n is 5, n is 6. So really we're just going to plug this in and make sure that it gives us 11/4. So my 6th term should be 11/4. Okay, that's what it should be. If my formula is correct, it should give me that. 6 minus 1/4. So half of 6 is 3 minus 1/4. Well, if I get common denominators, if I multiply 3 by 4 on the bottom and on the top, I get 12/4 minus 1/4, which is 11/4. So this will generate any term that I'm after. So if I wanted to find the 100th term, okay, I would just plug 100 in there for the n. I would have 1/2 times 100 minus 1/4. So half of 100 is 50 minus 1/4. So if I change that to fourths, I'd multiply top and bottom by 4. That would be 200/4 minus 1/4. So that would be 199/4. That would be the 100th term. Okay, so that's why that's nice, is it will generate whatever term that I'm after, okay? So we'll do some more examples of that on the next page, but that's that general idea for this one. Okay, so the important part is that c, a1 minus d, okay? Now the next one says it's geometric. Geometric means we multiply by the same thing each time. So I'm looking at this, I'm like, well, they're all 4s on the bottom. Maybe it's easier to see if we reduce. 1/4, 1/2, 1, 2, 4, 8. 32 divided by 4 is 8. 16 divided by 4 is 4. 8 divided by 4 is 2. 4 divided by 4 is 1. 2 divided by 4 is 1/2. So this is my first term, second term, third term, fourth term, fifth term, sixth term. Okay, so that's my terms on this. So now we know our terms, and we can see this. Oh, I see that we're just multiplying by 2 each time. That means r equals 2. So now it says to find the general equation, all I need is the first term and r. So an equals my first term, which is 1/4, times r, and this is always n minus 1. Okay, so say I wanted to find the next term, the seventh term, which we know is going to be 16 because we're multiplying by 2. But let's just see how that would work. I plug a 7 in for n. 1/4 of 2, 7 minus 1. Well, 7 minus 1 is 6. So 1/4 of 2 to the 6th. So I go to my calculator. 1/4 now my calculator's not going to work. 1/4 times 2 to the 6th power. Oh, and it says it's 16, which is what we hoped it would be because that's what it should be. So this will help you find whatever term you're after, and that's the general equation to find any term in that sequence, okay? So now let's move on to the couple of examples. I want you to come up with the general equation for all 4 of these problems. So go ahead and hit pause, try to do it. I'll go through with the answers. And I want you to come up with the equation for each of these. I split C up. It should really be up here. But come up with the general equation for each of those. Mark, set, go. All right, hopefully you paused. Now you're working on it. Remember this C really stands for the term before. So 3 to 7 is 4. 7 to 11 is 4. 11 to 15 is 4. 15 to 9 is 4. So what's 4 less than 3? Well, that would be -1, and that is C. Okay, you really could have used C equals A1 minus D. So 3 minus 4 is -1. So this C is going to be replaced with -1. There's always an N, that's like your X, and the difference is 4. So there's my equation, AN equals 4N minus 1. This next one, I'm going down by 3 each time, so that means this has to be 3 bigger than 5, so that's going to be 8. If I did it this way, that would be 5 minus a -3, because 5 to 2 is 3, 2 to -1 is, so I'm going down by 3 each time. So minus a minus turns into a plus, and I get that C equals 8. So in my equation, AN equals DN plus C. My difference is -3, and my C is 8. Okay. All right, the next one, geometric. 2 times what is 6? 6 times what is 18? 18 times what is 54? Or I could just go 162 divided by 54 is 3. So if you take any consecutive numbers and take the last one divided by the one in front of it, it will give you the R if it's geometric. Okay, so 2 times 3 is 6, 6 times 3 is 18, 18 times 3 is 54, so that's the R. Now I just plug stuff in. My first term is 2, my R is 3, and minus 1. That's my general equation. Now on this one, it might be easier to start at the end. 4 is half of 8, 8's half of 16, 16's half of 32, 32 is half of 64, 64 half is half of 128. So that means R is 1/2. So AN equals my first term, which is 128. R is 1/2 to the n minus 1 power. Okay. All right. Next question. Don't worry about this stuff down here. We'll get to that. So at the very top, it says I want you to add these together. So 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 4 is 10. 10 plus 5 is 15. 15 plus 6 is 21. Plus 7 is 28. 28 plus 8 is 36. 36 plus 9 is 45. 45 plus 10 is 55. So that's adding them together. But man, what if I ask you to add 1 to 100 together? That's going to take forever to do what I just did. is you're probably going to have to pull out a calculator, at least I would, and have to start trying to figure out what it is. So let's use this and see if we can find a pattern. So if I look at this, 1 plus 10 is 11. Well, what good does that do? But now watch. 2 plus 9 is also 11. 8 plus 3 is another 11. 4 plus 7 is another 11. 5 plus 6 is another 11. Oh, and that's all of them. And look, there's 5 11s. It's just 5 times 11 is 55. Well, that's convenient. You know, that's a lot easier to, there's a pattern. And not only that, but all of these are the same. So once I figure out what 1 plus 10 is, the first and the last, all of them are going to add up to be the same number. And these are pairs. So if I know how many terms there are, I can just divide that by 2, and that will tell me how many pairs of this number there are. Oh, so that's pretty nice. So 1 plus 100 is 101. If I count 1 to 100, that means there's 100 terms. So 100 terms, so I cut that in half, is 50. So 50 times 101 is 5,050. So that's the sum of 1, 2, 3, 4, 5, 6, up through 100 added together. So in using that idea, we're going to create a general equation for this. So Sn of arithmetic, that means the sum of a finite number of terms, equals n divided by 2, the first term plus the last term. Okay, so in this case, there were 100 terms, so n was 100. The sum of the first 100 terms, the first term was a 1, and the last term was 100. Okay? Now looking at this, this is the same exact thing. I'm going to replace n with 1, and then I replace n with 2, and then n with 3, and then n with 4. So this is going to generate all my numbers up to 100. Okay? So that's all that this means. This is exactly the same problem as adding all those up together. That's what that means. So when it's like this, the first term is when you plug this in. The last term is when you plug the top number in for n. And then if it starts at 1, that's going to tell me how many terms there are. Okay, so there are 100 terms. Now on this one, it doesn't start at 1. 3 is 2 more than 1. So instead of there being 17, we've cut off 2 terms. So there's only actually 15 terms in this. So I'm going to plug that into my formula. I'm going to have 15 divided by 2. My first term is when I plug this 3 in. So 2 times 3 is 6, plus 3 more is 9. And then I'm going to plug this 17 in there for n. So 2 times 17 is 34, plus 3 more is 37. So 9 plus 37 is 46. And we're going to times that by 15 divided by 2. So 15 divided by 2 times that by 46. And I get that it's 345. So if you're to come up with all the terms by plugging 3 to 17 into this, and then added them all together, you'd get 345. So that's the convenience of this formula, and having it written in this form is you can just figure out what your first term, the first term in the order in the sequence is, and the last term, and you can figure out how many terms there are. Okay, just so you guys know, if I take 10 minus 1, that only gives me 9. So the difference between 10 and 1 is 9. But there's actually 10 terms, because how far is it to get from 1 to 10? Well, you have to go up 9 more, but that doesn't include the first term. So if I go 17 minus 3 is 14, the number of terms is 1 more than that. It's 15. Because from 3 to 17 is 14 more, but we don't include the one we start at. It's saying I have to go 14 more spots from 3 to get to 17. But we're starting on 3, so I have to add that 1 more onto there to get to the number of terms. Okay, so if I had something like this, n equals 7 to 45. 45 minus 7 is 38. So that's how far I have to go from 7 to get to 45. I have to add 38 more. But there's 1 more because we have to include 7. So there would be 39 terms. Okay? So make sure when you subtract those that you understand that when you subtract them, you're not including the one you started with, okay? So you have to put one more than your answer after you subtract to get the number of terms. All right, the next one is the sum of an infinite geometric series. This is saying it's going to go on forever and ever and ever and ever and ever. This only works when r is smaller than 1 or bigger than -1. So r has to be a decimal, okay? Well, like it could be a half, it could be a fourth, it could be 0.8, it could be -0.7, it could be -0.1/3, not 0.1/3, -1/3, -0.37. So anything that's between -1 and +1, that works for this. The reason being, just to give you a quick example, if I start with a number, say 10, and I say the r is half, so I take half of it each time. Okay, if I keep doing this, notice that my numbers keep getting smaller, and that works if r is less than 1/2. The numbers get so small eventually that they start using this e to the -5 stuff or whatever. That means I'd move the arrow, this decimal place, 6 places over, so there'd be 5 zeros. So these numbers are getting super duper small. In fact, they get so small that it's like we add nothing onto it eventually. So it's infinite in that they keep going, but it's small enough that it makes no difference. So there's a nice little formula for it. If it's an infinite sequence, okay, so if it's infinite, so then it's probably a series, not, okay, so for geometric, probably say series. And then the r is smaller than 1, but bigger than -1, I can use this nice little formula. All that I do is say my first term is 10, 1 minus r is 1/2. So 1 minus 1/2 is 1/2. Dividing by a fraction is the same as multiplying by its reciprocal, so that's 20. Now, the reality is it's probably not 20, but it's so close, you would never know it's not 20. It's like this forever. Okay, this keeps going on forever. So this number is so small out here that when you were to look at it, it would look exactly like 20 because you're so far out here with these 9s that like this number, and this isn't even, so think of how small this number is. If you added that onto this, it would make it turn into 20. This number is so small, you'd never even notice it. Okay, and that's not even how small the number is because it keeps going forever. So think of how small this thing could get out there forever. So even though it says it's 19.9999 forever, it's so close you'd never know it's not 20. Okay, so anyways, that's how the infinite one works. Now, the same idea of this is how it looks versus this up here, okay? And the first term, if I were to write this, would be 10, 1/2 to the n minus 1. So now, to get the first term, I'd plug 1 into here, so I'd have 10. Ooh. Purple's not a good color to use. 10, 1/2, 1 minus 1. 1 minus 1 is 0, so I'd have 1/2 to the 0 power. Anything to the 0 power is 1, so 10 times 1 is 10. So that's my first term. The number in here is r, so that means r is less than 1 and bigger than -1. So that r works for this, and so now I just plug it into this formula, and voila, we're done, okay? All right, the sum of a finite. Infinite means it keeps going on forever and ever, so if it has the n in there, it means infinite, it keeps going forever and ever. Finite means it ends, okay? So this is saying I start at 5, I get to 10, 20. Oh, I'm multiplying by 2. So my first term is 5. I multiply that by 2. I get 10. Multiply that by 2. So really what I have is 5 times 2 is 10. This is 5 times 2 more, because that's 20. Times this by 2 more is 40. Times that by 2 more is 80, which is really this. So notice how there's one more 2 each time. 5 times 2 times 2 times 2 times 2 times 2. So if you notice this is 2 to the 1 power, 2 squared, 2 cubed, 2 fourth, 2 to the 5th. So 320 is 2 to the 6th. 640 is 2 to the 7th. 1,280 is 5 times 2 to the 8th. 2,560 is 5 times 2 to the 9th. And then we get 5,120, which is 5 times 2 to the 10th. So you're asking yourself, why did you just go through all that work to do what you just did? Well, over here, if you look, there's a formula that says if it's a finite geometric series, we don't care what r is, but we just calculated r to be 2 because 5 times 2 is 10, 10 times 2 is 20, and if I keep multiplying by 2, I end up at 5,120. So I know what r is, and I know my first term. So I can plug that stuff into this equation. That looks a little bit daunting, but it's really not. We need to fill in that number. All over 1 minus r. Well, that's the number of terms. So there's 1 term, 2 terms, 3 terms, 4 terms, 5 terms, 6 terms, 7 terms, 8 terms, 9 terms, 10 terms, 11 terms. And now, whoops, r is 2. Now I can just type it in my calculator. 2 to the 11th power. 2,048. So 1 minus that number. 1 minus 2,048. Negative 2,047. So what I have is 5 times negative 2,047, all divided by 1 minus 2, which is negative 1. Okay, so I'm going to go 5 times that number, divide it by negative 1. So it's 10,235. And you could have just added these all together, 5 plus 10 plus 20 plus 40 plus 80. So you could have just added these all together, and it would give you the same answer as this. Okay, there is another way to calculate what this r value is. Realize 5,120 is my last term. So if you remember, a to the n equals a1 r to the n minus 1, right? Well, I don't know what n is, but I know that the last term is 5,120. My first term is 5. R is 2 to the n minus 1. So I'm going to get this 2 to the n minus 1 alone. So I divide it all by 5. So I come to my calculator. 5,120 divided by 5 is 1,024. So I have 1,024 equals 2 to the n minus 1. If you remember our logarithms, remember a logarithm is how we can rewrite this so that the base of this n minus 1 is over on the other side, and I just have n minus 1. So I have log base 2 of 1,024 equals n minus 1. So remember, we can go to our calculator and do that. We can use what's called a change of base. So I go log 1,024 divided by log 2. So I go log 1,024, enter, divided by log 2. And it tells me it's 10. So this is 10. So I have 10 equals n minus 1. I add the 1. I get the n equals 11. So see how we have that 11 right there? That's another way to do it, okay? If you have the right kind of calculator, you can do it this way. You can go math, log base 2, 1,024. Okay, so that's just another way to come up with the number of terms there are to calculate the n for this. Also, the right kind of calculator, if I have it written like this, I can actually type this into my calculator. So I hit math, see that summation one right there? And it brings this up. I'm just going to use x. I'm going to go from 1 to 11. Whoops, not 111. And then I have, my first term was 5 times 2 to the x minus 1. So that's just typing in this formula. Instead of an n, I just used x. Okay. It tells me it's 10,235. So much shorter way once you can figure this out. Okay. Anyways, that's your the notes. Hopefully that helps clarify a lot of what you did on math is fun. Some of the notation, you know, this sigma notation, which means the sum of everything, geometric series, geometric sequences, the sum of them. You know, I think that's the 5 videos or 5 math is fun website topics that I had you guys do. I hope. So anyways, hopefully this helps clarify it and will help you do your worksheet.